Welcome to the next topic, battery inverters. What we will cover in this topic is what the different battery inverter types are, what the standard system voltages are, what the battery inverter functions are, and basic operations of a battery inverter. So without further ado, let's jump right in. Firstly, let's have a look at what a battery inverter is and where does it fit into a solar system. So if you've got this diagram representing a solar system, this would be your grid. This would be your grid. This your loads. This your battery, your charge controller, and your solar array. And your battery inverter would be here. So the battery inverter is basically located between the AC and DC part of your system, and its main function is to convert direct current into alternating current and vice versa. So it basically converts the 48 volts on this side, DC on this side, to 220 volts on this side, and the other way around as well, 220 volts on this side into 48 volt DC on this side. It basically manages the flow of energy between the DC and AC sides of your system. To better understand a battery inverter, we can contrast it with a PV inverter, also called a grid-tied inverter. There are basically two main types of inverters, grid-tied inverters and battery inverters. On the left image is a system of diagram of a grid-tied system or PV inverter. So the solar panels is just connected directly to the PV inverter and connected to the local grid. This system is totally dependent on the grid. If the grid falls away, it also switches off immediately. So it can't function without a grid at all. On the right hand side is an image of a battery inverter based solar system. So all the loads connected to the grid will also stop working when the grid fails, but all the loads connected to the backup power supply from the battery inverter will still work. And that will be supplied with power that was stored in the battery, or energy stored in the battery, and from the solar system. So it basically creates its own local grid for those loads. Okay, to further explain battery and PV inverters, this is typically what PV inverters will look like. Just to reiterate, it doesn't work when there's no grid, it shuts down, and there's no connection for batteries. So just a connection for your PV panels and for your grid. On the other hand, this is what battery inverters typically looks like. It can work when there's no grid, and you can connect 48 volt batteries to it. Synonyms for grid-tied inverter is also called sometimes a PV inverter, and for battery inverter is sometimes called a backup inverter or inverter charger or a hybrid inverter. All refers to the same thing. Battery inverters can further be grouped into three main types: off-grid inverters, off-grid inverter chargers, and grid interactive inverter chargers, also called hybrid inverter chargers. Let's go into more detail now. So off-grid inverters has no charger for batteries. Batteries can be charged by solar or external charger. Off-grid inverter chargers, inverter and charger is included in one device. The device functions like a UPS or uninterruptible power supply. So it supplies power to the loads if there's no grid, and if there's a grid, it just lets the power of the grid directly through. It doesn't synchronize with the grid at all. And the third type, or grid interactive inverter charger, also called a hybrid inverter. So again, the inverter charger is in one device, but here the device synchronizes with the grid, and it also functions like a UPS, but it can also function like a grid-tied inverter. So it synchronizes with the grid and it's able to export power to the grid or import power from the grid. So energy flows dynamically between the grid, loads, battery and solar, and the inverter manages all of that. Here we have some pictures of different types of inverters, just so that you can see what it looks like. So off-grid inverters typically look like that. Your off-grid inverter charger would look like this, and your grid interactive inverter chargers, hybrid inverters, would look like this. Great, let's have a look at standard system voltages now. What is that about? Basically, solar systems are designed to a standard specific system voltage, either 12, 24, 36, 48 or 96 volts. So multiples of 12. So each time you put a 12 volt series battery in series with another 12 volt battery, the system voltage increases by 12 volts. That means all components in the system needs to match the specific system voltage. The battery, the charge controller, the inverter, battery inverter, and the DC loads all needs to be compatible with the same system voltage. And these components are manufactured with that specific system voltage in mind, and one needs to select the right voltage when ordering and buying these components. And one would always try and select the highest system voltage possible. You might ask why. We'll have a look at that reasons right now. So why should one always select the highest system voltage possible? Basically, a higher voltage means more power for the same current. So the same component, for example, an MPPT, can handle more power at a higher system voltage than at a lower system voltage. For example, a 50 amp MPPT at 12 volt can handle 600 watts of power. But if it were connected to a 24 volt battery, it can handle up to 1200 watts of solar power. And at 48 volts, even double that, 2400 watts of solar power. So typically MPPT would look like that. And it all relates back to our power triangle, where power equals current times voltage. Another advantage is that one is able to use thinner cables because voltage drops has a lower effect on higher system voltages, and also thinner cables can process or handle more power at higher system voltages. Let's have a deeper look now at the different features and functions of the battery inverter. We're familiar with this diagram by now, where your battery inverter is the interface between the AC and the DC parts of the solar system. Another way to represent a solar system is with this diagram, where you also got your PV power here, your battery here, so all the DC on the bottom, your AC on the right here, your inverter in the middle, and your grid here on the left. So let's have a look at the different features and functions now. So obviously it's a pure sine wave inverter and battery charger in one device. It's the interface between all the different sources, which is your grid, battery and PV power, and your loads. So it's the interface between the loads and these three sources. It converts AC power to DC power, so power can flow from the grid into the battery to charge the battery. And also it can convert the DC power obviously to AC power from the PV panels or the battery to the AC loads or to the grid even. So if it's grid interactive, it can export excess energy to the grid. That will happen when the battery is full and there's not enough AC loads, or there's more PV power than what the loads are consuming and the batteries are full. Then the extra energy can flow back to the grid if allowed. And it also has a UPS function. So that means if the grid falls away within milliseconds, the inverter will switch from pass-through mode to backup mode and supply power from the batteries and the solar panel and not from the grid anymore. And lastly, it's got a data logging function, so it will log statistics about the grid, your loads, the battery and your solar power, and that can be useful to monitor and to optimize your solar system over time. Some more functions of the battery inverter is battery management. So battery charging and discharging. So it will protect the battery from being overcharged. So overcharge protection. So if the battery is full, then it will stop the flow of energy to the battery as to protect the battery. And also depth of discharge protection. So one can set how deeply one wants to discharge the battery. For lithium ion, typically up to 70 or 80% depth of discharge, the state of charge. And if it reaches, say, 20% state of charge, then the inverter will shut down and not supply power or energy to the AC loads anymore, as to protect the battery. So batteries get damaged if they get discharged too deeply, and that's why you can set the depth of discharge, how deeply it should be discharged, and it will cut down at that point. One can also program the inverter to normally cycle the battery each day as low as possible, or to keep the batteries full. That's useful in situation where there's a lot of power failures, and one wants the battery to be full in case of a power failure, to be able to supply the AC loads. Typically in countries like South Africa where there's load shedding, you want to keep the batteries full if there's a lot of load shedding. Great, now that we've covered battery inverter types, standard system voltages, inverter features and functions, let us have a look at protective measures. So on a DC, there's no DC reverse polarity protection, so be careful when connecting up the battery to the inverters that it's the right polarity around, otherwise there will be no protection for it and it will break the inverter. On the AC side, it's got a AC current limiter to protect the generator or the inverter itself. So that means if the load pulls more power than what the inverter is designed for, it will start deregulating or shutting down. Also when there's an AC short circuit, and AC frequency monitoring. So if the generator or the grid goes without outside the set frequency range, then it will also not connect to that source. On temperature, it's got an overheating protection built in. So if it starts getting hot, it starts reducing its charging current, or even shutting down if it gets too hot. And also there's battery sensing, battery temperature sensors on the batteries that can also stop the charging or discharging of batteries if the temperature goes out of range. And as already mentioned, the battery depth of discharge protection and overcharge protection. Great, that's it for this module. I hope that clarified a bit more about battery inverters, its different features and functions, and where it fits in the system and how it works. So hope to see you in the next video.